cognitive load, and in particular cognitive overload, which is when there's too much cognitive load and that gets in the way of learning. And we're going to do this through a practical session where I deliberately teach you something in a way that's not very good so that you experience cognitive overload. So we can see what that feels like. And the reason for doing this is hopefully that will help us all remember how that's not very good. And so therefore we will teach better ourselves and not overwhelm our students by trying to teach too much. So cognitive scientists tell us that our working memory is fixed and limited and easily overwhelmed. And they say, probably we can only think about 4 things at once. And if you try and squeeze in that little bit extra and that little bit more and a little bit more, then we just become overwhelmed and learning doesn't happen. The sort of learning seeps in your brain and out again. So we're going to experiment with that and have a go ourselves at learning something by learning to tell the time on a Fibonacci clock. Now, this is a Fibonacci clock, very beautiful piece of equipment. If anyone wants to buy me one, they're online, I'll be delighted. So how do you tell the time using a Fibonacci clock? Well, first of all, we need to know about the Fibonacci sequence. So maths teachers, bear with me. I know that you know, but for those of us that don't know, the Fibonacci sequence is a sequence of numbers. And to find the next number in the sequence, or the next term, to give it its proper name, then the rule is you add the 2 preceding numbers together. So it starts off with 0 and 1. So to find the next term, you add 0 and 1 together. And so the next term is 1, because 0 and 1 is 1. And then we add the 2 preceding terms together. So now we've got 1 and 1. So that makes 2. And then the next term is 1 and 2. So that's 3. And the next one is 2 and 3. It's 5. Like this, you see? And so, 2 and 3 is 5. 3 and 5 is 8. 8 and 5 is 13. 8 and 13 is 21, etc., etc. And that's the Fibonacci sequence, which goes on and on to infinity. So if you draw that as squares, each with the side of one of the numbers, you get a pattern like this. So see 1, 1, 2, 3, 5, 8, 13, 21, and then you could go on and on and on. But what's interesting here is that you can draw a spiral that links those together. So if you look here, and you start at one corner of the 1 and take it to the other corner, and then round in a spiral, you get this spiral pattern going outwards. And that very same spiral pattern is seen in nature. It's seen in pineapples, and that the bumps on the pineapple make a spiral that's in this pattern, and so do pine cones, and so do cauliflowers, and the walls in the middle of daisies. All of them have the same pattern, and shells on them, nautiluses and snails, and so on and so forth. If you want to know more about that, have a look at this Khan Academy video. It's really, really interesting. Don't look now. Carry on listening to me and then listen to some other ones in the series, but then later have a go. It's really good. So back to Fibonacci. So here is our pattern again. And just have a look now at the rectangle within the rectangle that has 1, 1, 2, 3, 5 in it. It's that rectangle. It looks like this. And now let's rotate it on its side. 1, 1, 2, 3, 5. Here it is, the 1, 1, 2, 3, 5. So you can see 1, 1, 2, 3, 5. So that's our Fibonacci clock. 1, 1, 2, 3, 5. So here are the rules. Here are the rules to tell the time using a Fibonacci clock. The hours are displayed using red and the minutes using green. Really simple. Hours are red, minutes are green. Minutes are a little bit more tricky because to work out the minutes, you add up the green squares and then you multiply by 5. So hours, you don't need to do that. You just add up the values of the reds. Greens, you add up and then you multiply by 5. Well, just not a rule, but it's only accurate to 5 minutes. Okay, should we have a go? Right. You have a go? So remember, hours are red. So we've got a blue square, a red square that's worth 2 and a red square that's worth 5. 2 and 5 is 7. So the time on the Fibonacci clock is 7 o'clock. Okay, this one's a little bit harder. Always do the hours first. I find in my experience is easier. So let's do the hours first. We've got a 1 and a 2 and a 3. 1 plus 2 plus 3 is 6. So it's 6 o'clock and some minutes. Let's do the minutes. We've got a 1 and a 5, which is also 6. So it's 6, 6. No, it's not, because remember the minutes, you have to multiply by 5. So it's 6 times 5, so that's 30. So it's 6 hours and 30 minutes. So it's 6:30. Okay? Right, I slightly misled you there because there is actually a third rule. The hours are red and the minutes are green, but sometimes you need to use the same square for both hours and minutes. Excuse me. So when a square is used to display both the hours and the minutes, it's blue. So that means to work out the hours, you just add up the red and the blue squares. Okay, that's the hours. But to work out the minutes, you add up the green and the blue squares and multiply by 5. Do we have a go? Let's do the hours first. There's no red, so we just want the blues. The blue is 5, so it's 5 something. Now we can go to the minutes. The minutes is, what's that, 3 and 1? So that's 4 times 5 is 20. So it's 5:20. No, I've done that wrong. What have I done that wrong? I forgot the blue. So the green, I forgot the blue for the minutes. So it's 5 for the hours, that's right. But I've got 3 and 1 is 4 and 5. So that's 8, 9. 9 times 5 is 45. Sorry about that, everybody. 5:45. Don't forget, blue is minutes as well as hours. Okay, well, I'm going to get this one right this time. Okay, so I'm going to do the hours first. So I've got a red one and a blue one. So that's a 1 and a 5. So that's 6. And then the minutes, that's also going to be 6. 6 5s are 30. So it is going to be 6:30. Hooray, got that one right. Okay, let's try this one. Hours first. I've got a 1 and a 2 and a 3. 1, 2, that's 6. So it's 6 something. And then the minutes, I've got a 1 and a 2 and a 3, also 6. Oh, that's 6:30 again. That's because in the Fibonacci clock, you have duplicates where the same time can be configured with different looking screens. Okay, let's do this one. Hours first. It is 5 and 1, 6 and 3, 9. Okay, so the 5 that's red, 1 that's red, 6 and 3, it's blue, 9. So 9 something, and then the minutes, I've got a 2 and a 3, which is 5 times 5 is 25. So it is, I've forgotten how many hours now, 9:25? Phew, got that one right. Okay, so you can see even when you've been doing it a few times, I've done this presentation a few times, but not for a while, it gives you a bit of a workout mentally. Okay, so just remind ourselves of the rules. The hours are displayed using red and the minutes using green. When a square is used to display both the hours and the minutes, it turns blue. To work out the hours, just add up the red and the blue squares. To work out the minutes, add up the green and the blue squares, and remember, multiply by 5. Let's compare that with telling the time using an analog clock. And if any of you have tried to teach young children how to tell the time with an analog clock, you probably realize most teachers would say it's one of the hardest things to teach. Let's look at why. Let's look at the rules for an analog clock. So the hours are displayed using the short hand and the minutes using the long hand. So that's not that different from our Fibonacci clock. To work out the hours, just see which number the hand is pointing to. That's very straightforward. To work out the minutes, that's where it all goes horribly wrong. For the minutes 1 to 6, for numbers 1 to 6, just count round in 5 starting at 0. That's really quite complicated. To work out the minutes for numbers 7 to 11, count round backwards in 5 starting at 11. This is why children find it hard, because it is hard. It's really complicated. Lots of moving parts. It's too tricky. It's too much. They're cognitively overwhelmed. So to get round that, we need to break the material into small steps, little bit at a time. Because whenever a child is struggling with something, it's always worth considering, is it because we've overwhelmed their working memory, because we've underestimated how complex something is? We have what is known as the curse of knowledge, or the curse of the expert, because we are expert time tellers. We can read analog clocks. And therefore, we underestimate all the little composite little steps that go into being able to do it. And we underestimate that, so we teach it in too big a slab of stuff that overwhelms people's cognitive load. But there is an easy way to cut down the cognitive load involving in telling the time, and that's by separating out learning how to tell the time using the hour hand and learning how to do it using the minute hand. Don't muddle them up and try and teach them both at once. If you think about it, the hour hand counts in ones, the minute hand counts in fives, and also indicates fractions. That's really confusing. No wonder children find it hard. So instead of doing that, don't teach the hour and the minute hands at the same time. Just teach the hour hands only. And when that is secure, even if it takes a year, it doesn't matter. Leave it. Don't do it in year one. Just stop. Just do the hour hands. And then when they're really good at that, then you introduce the minute hand. So here's a screenshot of my Apple Watch. So I just look at that and I just go, it's 10 past 10 and 20 seconds. I don't count round in fives. I don't have to think about it at all. I just know it automatically. And I know it automatically because I've done it so many times. And also because many, many years ago when I was first learning the time, I did used to count rounds in fives. I did used to have to follow the rules to do it. But because I did that and then did it a lot, I acquired what's called automaticity. I can just do it just like that. So when we're learning something like that, like telling the time and learning to read, we need to learn the rules first and do lots and lots of thinking. Early on, it's really hard work, lots of thinking going on. And then we practice lots. And then eventually it becomes automatic and we don't need to think about it anymore. You just know. Very much like driving a car. When you're first driving a car, you need to really think hard about the gears and the clutch and the steering and the signaling and, not killing anyone. Really hard work, and then you need to practice lots. But then eventually, maybe a year later, you drive home, you don't even remember what you did. It's just automatic. You don't really have to think about it very much. So I'm not going to go on and explain about how you could teach someone to tell the time only using hour hand first. But if you want to know about that, I've written a blog about it, and it's on the Third Space Learning blog. There's the link there. But instead, we're going to go back to our Fibonacci clock and think about, say we had to, for some reason, teach people how to tell the time using a Fibonacci clock, what would be a good way of doing it that didn't cognitively overwhelm them? Well, probably we'd just start on the hours and just the red hours and practice loads of those until we could just recognize them automatically. So it was really, really quick. And we'd do that way before we did anything a bit more complicated. So let's have a go at that. Okay. So what's the time? Yes, it's 1 o'clock. Yes, it's 2 o'clock. Remember duplicates, that's also 2 o'clock. 3 o'clock, also 3 o'clock. 4 o'clock, also 4 o'clock. 5 o'clock, also 5 o'clock. Also 5 o'clock. 6 o'clock. Also 6 o'clock, and remember that pattern, it's quite an easy one to remember. It's quite pretty with a hole in the middle. 5, 6, 7. 7 o'clock. Also 7 o'clock. Now have a look at that one. See how the whole of the left-hand side is coloured in? That side equals 7. The value of that side is 7. And that side, the value of that is 5. Just bear that in mind. And together, it makes 12. And just look how it can be a bit confusing because the area of 5 is bigger than the area of 7. So don't let that trip you up. So we've got a 5 and a 3. So that must be 8 o'clock. 5 and a 2 and a 1. 8 o'clock again. What's this one? Yes, it's 9 o'clock because it's a 5 and a 3 and a 1. So it's 9 o'clock. I've got a 5 and a 2, so it's 7, 8, 9, also 9 o'clock. What about this one? Well, that's 10 o'clock, and I've got a sneaky way of doing this. because by now it's easier to use subtraction than addition, because I know the whole thing is 12, take away 2, 10. Also 10. 12 take away 1, 11. That's another one. See that pattern there? Really easy to remember. You can just recognize that automatically. So initially we need the rules. Otherwise, if we had to learn each picture individually and what it was worth, there'd be far too many. It would drive us nuts. There'd be too many to learn. So we use the rules first. We have to crack the code, learn the code, and then use the code. But eventually, if we do that lots and lots of lots, we will see them as pictures. And that mirrors the process of learning to read, where you have to start off with phonics and learn how that code operates. But then eventually with practice, we get orthographic recognition in reading, and we just recognize whole words. 12 o'clock. Now, I said there was only 4 rules. I promise you there weren't any more. I lied. There's actually another rule, and that is if none of them are coloured in, it's 12 o'clock. Bit like with a 24-hour clock, but 24-hour clock can be written as 2400 or 0000. It's just one of those arbitrary things. So that is 12 o'clock. That is 12 o'clock. That is 12 o'clock. So we want to acquire automaticity so we can just tell. That's 10, that's 6. I don't need to work it out. I just know those. And that is, what is it, everybody? Yes, it's 11. Ready for the next one? What's the next one going to be? It's 11, but it's blue, so that means we've got the minutes as well. So it's 11 o'clock and 55. It's 11:55. So this quote from Suella Ayres and Kaluga, when I first saw it, I was a bit surprised. Novices use thinking skills, experts use knowledge, because I was always like, no, thinking skills is like the end game, this thing we're always meant to be pushing students to do, rather than what beginners do. But actually, if you think about it, when you're a beginner, that's when you're thinking hard. When you're an expert, you don't need to think hard. You've got the knowledge there that does the work for you. That's the whole point. Just like when you drive, beginners have to concentrate so hard on everything. But when you're an experienced driver, you don't have to concentrate that hard because your knowledge does that work for you. So that being the case, this helps us think about problem solving and the role of problem solving in learning. And problem solving is obviously a good thing to do, but we shouldn't do it too early in the learning journey, because at the beginning of the learning journey, when you're first learning something, you need to concentrate on acquiring the basics and acquiring and practicing, following the rules, knowing what the rules are. And then over time, when it's more automatic, then you're ready for problem solving. So we're going to do the opposite of that and do it badly and try and problem solve, even though you're nowhere near ready for it because you don't know enough about telling the time using a Fibonacci clock. But we're going to try and problem solve by working out what will the clock look like 5 minutes later. So have a look at that and see if you can think about what will look like 5 minutes later. If you put that, that's correct. It's not the most efficient or elegant solution, but it's still fine. That would be a more elegant solution, or that, which basically they're the same thing. So as an expert, you would just recognize that as 9:25 straight away and just go, oh, it's 9:25, 5 minutes later, turn the red to blue. Then it will be 9:30. That's all I need to do. Whereas a novice has to remember the rules, work out the greens are worth, work out what the reds are worth, what the blues are, blah, 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 blah. A novice has an awful lot of things to do, which gets in the way. It means that problem solving is not a good use of their time. They're using their thinking skills. The experts are using their knowledge. So for the novice, their working memory is full up with working the answer out, which means they've got nothing left. They've got no capacity left to remember the methods that they used or the answer that they got. So the next time they come back to face a similar problem, they're back where they started with no greater knowledge than previously. So all that works for nothing. They got the answer, but they don't remember how they got there or what the answer was. Bit like if you've got hopelessly lost trying to find your way to somewhere, that you might get there in the end, but it's no good. It doesn't help you remember the journey next time. So instead of that, instead of getting novices, people at the very beginning of learning something, to solve problems, there's a time and a space for that, but not at the beginning. They should study solutions, or called worked examples, rather than solve problems. So let me, excuse me, do some worked examples. So the first thing I'm going to do to make it a bit easier is write those numbers on. So here we have the hours are, we've got 9, we've got 5, 1 and 3 for the hours. And for the minutes, we've got 2 and 3, so it's 9:25. Okay, we want 5 minutes later. So I'm just going to write this down as I work this out, making my thinking really explicit, thinking out loud. The red is equal to 6, 5 plus 1. The red and the blue, the hours are 6 plus 3, so that's 9. So it's 9 o'clock. My green is worth 2. My green and blue is worth 5. So for minutes, I need to multiply that by 5. So it's 9:25. So I'm really thinking out loud and showing you my thinking. Okay, so I'm not expecting you to do it. I'm showing you how I'm thinking. It's my scaffolding for you. And now I'm going, I need to add one small green square because I want it to be 5 minutes later. So I need one small green square. So instead of having 5 times 5, I've got 6 times 5, which is 30 minutes, not 25 minutes. And look, I've got a white square there. I could just turn that green. Oh, but I could also, instead of doing that, a more elegant solution, see the red one. If I turn that blue, my hours would be the same, but my minutes would have gone up by 5. Because the small green and the small red is the same as the small blue. So these two solutions are equivalent. They're the same, got the same value. So here we are 5 minutes later. The value of the squares that were blue or green went up by 1 small square. So instead of having a value of 5, it's now 6. So now it's 5 minutes later. So if I want it to be 5 minutes later again, to be 9:35, I need the value of the squares that are green or blue to go up again by 1 small square to 7. So now I've got 7 and my hours haven't changed. I don't want my hours to change. So let's just check through my thinking. So the hours are blue and red. So that's 3 and 1 and 5 is 9. So they're the same. But my minutes are blue and green. So the blue is 3 and 1 and then 2 and 1 for the green. Okay, that's 5, 6, 7 times 5, 35. So it's 9:35. Now, a really tricky challenge. Let's try and think of what it would look like 5 minutes later. It was 9:40. So I need my blue and my green to be 8, because if I want 40 minutes, I need 8 5s to be 40, but I need my blue and my red to stay 9. And that's tricky because look here, my blue and red to be 9, my blue and my green to be 8, because my left-hand side is full, because that, remember, the left-hand side equals 7. I can't change the small green to blue because that will also change the hours. And then instead of saying 9:40, it will say 10:40. So that's no good. So I'm going to have to change the big red 5 to blue, but then I'll have too many minutes. So then if I did that, if I just change the big red 5 to blue, it will say that will still be 9, but it'll be 9:60, which is no good. So I need to get rid of some of the greens so that I've just got 5. Because I'm at 9:40, I just need a value of 8. So here we are. There we are. Let's just talk you through that. So my hours are everything because it's blue and red. So it's 8, 9, which is I want. But my minutes, I just want the blue, not the red. 8. There we are. Tricky, see? So Adam Boxer wrote a really interesting blog about this based on the work of Frederick Reif. And he wrote that the cognitive load, we can think about it as a ratio between the demands of a task, how hard something is, and the available resources. And the harder a task is, if a task is getting harder, but you want to keep the cognitive load the same, well, you need to mitigate that with more resources. And by that, well, let's just have a look at that. Let's just work through that first. So let's just chuck some arbitrary numbers in to help us. So task demand is 10, and the resource is 2. 10 divided by 2 is 5, so the cognitive load is 5. Whereas if a task demand is just exactly the same as 10, but we have more resources, we have 10 times as many resources, look, the cognitive load is down to a half because 10 divided by 20 is a half. So exactly the same difficulty of demand of a task, but more resources, and that mitigates the cognitive load. And we can think of those resources in 2 different ways. we can think of internal resources, by which they mean our mental resources in our long-term memory, or external resources, so things outside of us that help us with our thinking. So those internal resources, that not working memory, our long-term memory, we can strengthen those and get more internal resource, more knowledge, in other words, through retrieval practice, space practice, and to leave practice, so that we have more knowledge. So therefore, we've got that knowledge to draw on. We don't have to think hard about it so much. It's just there for us. But if we don't have that knowledge yet, we can use external resources. So it might be a word wall, a calculator, a step-by-step guide. We can use something like that can help us fill in, can buttress against that cognitive load, keep the cognitive load excuse me, steady through using one of these things. So for example, do you remember I drew the numbers on the Fibonacci square? And outsourcing your working memory to paper and pencil is a really good way of reducing cognitive load. So do those math jottings, kids. Like we say, show you're working out. It extends your working memory for you. So if you want to practice telling the time using a Fibonacci clock, you can look on my blog, where I've written a blog that covers the same territories I've just talked to you about, but has lots of screenshots of clocks. So if you want to practice, have a go. But anyway, I hope that's been useful. I hope it helps you think about when you're planning learning, to have small steps, to provide resources where you need to, and to generally not try and teach too much at once, and don't do problem solving too quickly. Thank you, and see you soon.